Dear students, my today's topic is integration 1. In today's topic, we shall see how to integrate some functions using standard integrals, and we shall also see the first method of integration, that is method of substitution. Okay, we shall have a glance at a standard integrals once. You know what is integration? Integration is reverse process of differentiation. Okay, suppose d by dx of d by dx of capital F of x is small f of x, correct? Suppose derivative of, say, capital function f of x is another function small f of x, then we say that integral of f of x is capital F of x, correct? Integral of f of x equal to capital F of x plus c. So this is what is integration. So it is a reverse process of differentiation, and here c is integration constant and this is integration simple. Okay, now let us have a glance at the standard integral ones. Okay, now I want all of you to mug up these integrals. Okay, so integration of x power n plus 1 by n plus 1, and you also by heart integration of 1 by x power n. Integration of 1 by x power n is minus 1 by n minus 1 into x power n minus 1 plus c. And you treat 1 by root x and 1 by x square as standard integrals. Integration of 1 by root x is 2 root x plus c. Integration of 1 by x square is minus 1 by x plus c. Integration of e power x is e power x plus c. Integration of a power x, exponential function, a power x divided by log a plus c. What is integration of 1 by x? Integration of 1 by x is log mod x plus c. Next, integration of sin x. Let us see integrals of trigonometric function. Integration of sin x is minus cos x plus c. Integration of cos x dx, sin x plus c. Integration of tan x is log secant x plus c. Integration of cot x dx, log of sin x plus c. Integration of secant x dx is log of mod secant x plus tan x plus c. But for c you have to remember one more integral, log of tan of pi by 4 plus x by 2 plus c. Next, integration of cosecant x dx. I think you are familiar with this one, log cosecant x minus cot x plus c. But for CET you should remember one more integral, that is log tan x by 2 plus c. Okay, we shall now write down few standard integrals with the knowledge of derivatives. You know that derivative of tan x is secant square x. So integration of secant square x is tan x plus c. Integral of cosec square x dx is minus cot x plus c. Now what is derivative of secant x? Secant x into tan x. So integration of secant x into tan x is secant x plus c. And integral of cosecant x into cot x equal to minus cosec x plus c. Now let us see few more integrals. Integral of 1 by x square plus a square, 1 by tan inverse x by a plus c. Integration of 1 by x square minus a square, 1 by 2a log mod x minus a by x plus a plus c. Similarly, remember these three integrals. Okay, we shall now see one theorem. This is generalized standard. If integration of small f of x is capital F of x plus c, then theorem says integration of f of ax plus b means instead of x, what you have? Generalized term, linear term, ax plus b. But then how to write integral? Here integral is f of x, so replace x by ax plus b, and you should divide by a. So 1 by a f of ax plus b plus c. I will just give one example. integration of cos of 3x plus 10 dx equal to, how to write integral of this using this theorem? Integration of cos x is sin x, but instead of x here you have 3x plus 10. So sin of 3x plus 10 sin of ax plus b, sin of 3x plus 10 divided by a. Here what is a equal to 3. So divide by 3 plus c. Okay. Okay, we shall now solve few problems. Integration of 1 by sin square x into cos square x dx equal to. So 4 options are given. Now what you should do here? Here you should use formulae, you should use identities, you can do whatever you want, but finally you should try to get standard forms. Okay. So given integral equal to, now see, 1 by sin square into cos square is cosec square into cot square, but that is not standard integral. Here what technique has to be used, right? One is sin square x plus cos square x using identity. So sin square x plus cos square x divided by sin square x into cos square x dx equal to, now split sin square x by sin square x into cos square x. Sin square cancel. What do you get? Integration of 1 by cos square x plus cos square x by sin square x into cos square x. Cos square cancel. You get 1 by sin square x. Correct? Okay. This is equal to, now 1 by cos square x is secant square x. Correct? So integration of secant square x dx plus 1 by sin square is cosec square x. Cosec square x dx. Now no need to write. Integration of secant square x is tan x and integration of cosec square x is minus cot x. So what is the answer? Tan x minus cot x plus c. At the end you have to write integration part. So tan x minus cot x plus c. Second option. Second example. Integration of tan square 2x dx equal to. See, you remember you can integrate sin square, cos square, tan square, cot square, cosec square, secant square. Okay, all using formulae. Now tan square, how to integrate tan square? It is not standard integral. Use identity. Tan square theta equal to secant square theta minus 1. Correct? So given integral can be written as secant square 2x minus 1. Okay, because identity tan square theta equal to secant square theta minus 1. Now what is integration of secant square 2x? Integration of secant square x is tan x, but here instead of x you have 2x, so tan 2x. Correct? Tan 2x by 2 minus integration of 1 is x plus c. So which option? Tan 2x by 2 minus x plus c. Third option. Correct? Next example. Integration of sin x degrees dx equal to, it is sin of x degrees. Now see, integration of sin x is cos x, sorry, minus cos x, but there x must be measured in radians. Correct? Therefore first we have to convert degrees into radians. How to convert? There is one formula. X degree is equal to pi x by 180 radians. Correct? X degree is equal to pi into x divided by 180 radians. So given integral becomes, convert sin of x degrees pi into x divided by 180 radians. Correct? Now integrate. But here you have pi x by 180, generalized term. It is in the form of ax plus b. In place of a, what you have? Pi by 180. Correct? Now integration of sin x is minus cos x. So minus cos of pi x by 180 divided by a. What is a here? Pi by 180. Correct? So 5 by 180 plus c, which is equal to, when you simplify this, what you get? Pi by 180, go to the top, it becomes 180 by pi. So 180 by pi minus cos pi x by 180. So which option? First option. So minus 180 by pi cos of x degrees plus c, correct? Because cos pi x by 180 can be once again written as cos x degrees. No, convert radians into degrees again. So pi x by 180 radian is x degrees. And look at the first option. First option is suitable, correct? Minus 180 by pi cos x degree plus c. Next question. Integration of 1 by 1 plus cos x dx equal to. So 4 options are given. Now here use formula. 1 plus cos x is 2 cos square x by 2. Cos square x by 2 dx. See, remember, while performing integration, you should remember two very important formulae, correct? 1 plus cos x and 1 minus cos x. What is 1 plus cos x? 2 cos square x by 2. And 1 minus cos x, 2 sin square x by 2. 2 sin square x by 2, correct? These two are very important formulae. You will be using these two formulae frequently. So 1 plus cos 2 cos square x by 2, correct? Now 1 by 2 is constant, take it out. 1 by cos square secant square, correct? Secant square x by 2 dx. Now this is a standard integral. Integration of secant square x is tan x. But in place of x, you have generalized term x by 2, that is 1 by 2 into x. So 1 by 2 into tan of x by 2, correct? Divided by a. What is a here? Not 2. 1 by 2 into x, so 1 by 2. So what happens? 1 by 2, 1 by 2 cancel. So answer is tan of x by 2 plus c. So first option, okay? Next example, integrate secant x by secant x plus tan x dx. Okay, I think here we have to do one trick. What is that? Multiply numerator and denominator by same quantity. Because you know the identity. 1 plus tan square x equal to secant square x, correct? So what is secant square x minus tan x? Equal to 1. So let us try to get secant square x minus tan square x. So multiply numerator and denominator by secant x minus tan x. So given integral equal to secant x into secant x minus tan x divided by secant x plus tan x into secant x minus tan x. Here, so perform this trick. Now multiply secant x into secant x, secant square x, secant square minus secant x into tan x divided by a plus b into a minus b, a square minus b square. So secant square x minus tan square x, correct? Dx, which is equal to, now secant square x minus tan square x equal to 1. So denominator is 1. So it becomes integration of secant square x minus secant x into tan x, correct? Whole divided by 1. So you can ignore. Now see, both are standard integrals. Integration of secant square x is tan x minus integration of secant x into tan x, standard integral secant x minus secant x plus c. So option is tan x minus secant x plus c, second option. Next example, integration of dx by sin x plus cos x, or integration of 1 by sin x plus cos x dx equal to. Let's see how to solve this problem. Now, what happens if you multiply numerator and denominator by sin x by cos x? you get sin x minus cos x by denominator, sin square x minus cos square x. But that's of no use, correct? So this problem should be done in a different manner. Okay. Now here I am going to use this formula. Sin of a plus b equal to sin a cos b plus cos a sin b. Okay. So I want to convert denominator from sin x plus cos x into sin of something. For that you should do some trick. Multiply numerator and denominator by root 2. So given integral equal to dx by, now denominator can be written as root 2 into 1 by root 2 sin x plus 1 by root 2 cos x. Correct? So what did I do? I have multiplied and divided denominator by root 2. Multiply by root 2, divide by root 2. Now this is equal to, so 1 by root 2 take it out. 1 by root 2 take it out. So integration of 1 by, now 1 by root 2 can be written as cos 45. So sin x into cos pi by 4 plus, and this 1 by root 2 can be written as sin 45. Don't write it again as cos 45. Sin 45. So sin pi by 4 into cos x dx, which is equal to 1 by root 2 into integral of 1 by, now look at this, compare this and this. This is in the form of sin a cos b plus cos a sin b, sin of a plus b. So sin of a, that is x plus pi by 4 dx, correct? Which is equal to 1 by root 2 into, now 1 by sin theta cosec theta, cosec x plus pi by 4 plus dx, correct? Why? Because 1 by sin theta is cosec theta. Now recall integral of cosec x. One integral is log mod cosecant x minus cot x, but that is not here. Look at the option. That option is not there. That means you have to use one more. Which one? Integration of cosecant x dx equal to log tan x by 2 plus c. Use this one. But in place of x, what you have? X plus pi by 2. So in here also, in place of x by x plus pi by 4. So 1 by root 2 log tan of x by 2. But in place of x, right? X plus pi by 4 whole divided by 2 plus c. Correct? And you can ignore whole divided by 1. Here, what is coefficient of it? 1x. So a is 1. But since it is 1, no need to divide whole thing by 1. You can ignore that step. So what is the answer? 1 by root 2 log tan x by 2 plus pi by 4 by 2. Pi by 8 plus c. So which option? First one. 1 by root 2 log tan x by 2 plus pi by 4 plus c. Okay? We shall now move on to the next technique of integration, that is method of substitution. Now let's see how to solve a problem using method of substitution. Consider the problem, that is integration of e power x square into 2x dx. Now remember, in this method you will see the presence of function and derivative together. So whenever function and its derivative occurs in the problem, that is a hint for you that you have to think of solving that problem by method of substitution. Now see here, what is derivative of x square? 2x. Correct? Derivative of x square, how much? 2x. Okay? Hence, you have to put t equal to x square. So, put t equal to x square. Success of this method depends on proper substitution. Okay. So e power x square is t now. So e power t. Now what you have to do? What is remaining? 2x dx is remaining. You have to find out 2x dx exactly fit into how much? Differentiate. Differentiating with respect to it. dt by dx equal to 2x. Now use the language of differentials. What is the language of differential? When dt by dx equal to 2x, dt can be written as 2x into dx. This is called language of differential. We agree to cross multiply. So 2x dx exactly fit into dt. Now what is integration of e power t? E power t only. E power t plus c. Now last step is substituting back t. E power x square plus c. So this is method of substitution. Now in this method, in order to save time, okay, in order to avoid substitutions, you should practice. You have to, or you should remember few ready-made differentials. Now d by dx of sin x, what is it? d by dx of sin x, derivative of sin x is cos x. Now in language of differentials, we agree to cross multiply, that is d of sin x equal to cos x into dx. So remember by heart, d of sin x is cos x dx. If you know derivatives properly, it is not difficult for you to write differential on the spot. d of cos x is minus sin x dx, because derivative of cos x minus sin. What is d of x square? 2x dx. d of tan x is secant square x dx. d of sin inverse x, 1 by root of 1 minus x square dx. If you practice this while solving problems in CT, you can avoid making substitution and writing all the steps. I'll show you one example. Suppose problem is integrate sin x power 10 into cos x dx. Look at this problem. Here actually derivative of sin x is cos x. I told you in method of substitution, function and derivative will be visible. Derivative of sin x is cos x, visible. But how should we avoid writing all those substitution? Use language of differential. This can be written as sin x whole power 10, correct? Cos x dx is d of sin x, correct now? Here it is. d of sin x is cos x dx. Okay, so write cos x dx as d of sin x. Now look at this problem. Does it look like t power 10 dt? Is it not? It is similar to t power 10 dt. Only thing, in place of t you have sin x. What is integration of t power 10? T power 11 by 11 plus c, correct? So here you can write directly integration of sin x power 10 with respect to sin x is sin x power 11 by 11 plus c. See, I have written answer in 2 steps. I have avoided all those substitutions, correct? So this is how you should solve problem in method of substitution. Okay. Okay. Let us solve 1 or 2 examples. Integrate secant x power 100 into tan x dx. So you have to integrate secant x power 100 into tan x. Now here you have to quickly identify the presence of function and derivative. What is derivative of secant x? Secant x into tan x. So here you have only tan x. So one secant x can be liberated from secant x power 100, correct? So secant x power 100 can be written as secant x power 99 into secant x. So given integral can be written as secant x power 99 into secant x into tan x dx, correct now? So what you should do? Liberate one secant x from here. Then this becomes secant x power 99. Now secant x into tan x is derivative of secant x. Now just now I told you, you should use the language of differentials. So this can be written as secant x power 99 into d of secant x. What is differential of secant x? Secant x tan x dx. Now look at this problem. It is similar to this one. T power 99 dt, correct? And what is integral of t power 99? T power 100 by 100 plus c. But in place of t, what you have? Secant x. So answer is secant x power 100 by 100. So secant x power 100 by 100 plus c. So which option? First option. Next example. Integration of sin 2x by sin x power 4 plus cos x power 4 dx. Okay. Now this is not an easy problem because in this problem function and derivatives are not visible. Okay. In such a situation you should do some tricks like dividing numerator and denominator by same quantity, multiplying and dividing denominator by same quantity, etc. I think here we shall divide numerator and denominator by cos x power 4. So divide numerator and denominator by cos x power 4. Then given integral equal to, but what is sin 2x? 2 sin x cos x. 2 sin x cos x divided by cos x power 4. Okay. Now divide denominator also. Sin x power 4 plus cos x power 4 by cos x power 4. Okay. This is equal to, now cos cancel here, correct? Okay. 2 into cos cancel. What is left in the denominator? Cos cube. Sin by cos, tan. 2 tan x. Okay. Cos cube. Liberate 1 cos from cos cube. What is left? Cos square. 1 by cos square, secant square. Secant square. Divided by cos x power 4 by cos x power 4. 1. Correct? Plus sin x power 4 by cos x power 4. Tan x power 4. Which can be written as tan square x whole square, correct? Okay, this is sin by cos tan, so tan x power 4, which can be written as tan square x whole square. This is equal to, now you can see presence of function and derivative. Just observe, derivative of tan square x is 2 tan x into secant square x. So use the language of differential. Avoid putting t equal to tan square x, etc. Use that shortcut. What is that? D of tan square x. So 2 tan x secant square x can be directly written as d of tan square x divided by 1 plus tan square x whole square. Okay. Okay. Now look at this problem. It looks like integration of 1 by 1 plus t square dt, no? 1 by 1 plus t square dt. In place of t, what you have? Tan square x, okay? In place of t, you have tan square x. So just compare. What is integration of 1 by 1 plus t square? Tan inverse t, correct? So here it becomes tan inverse of t. But what is t? Tan square x. Tan square x plus c. So tan inverse of tan square x plus c, first option. Okay. Next example. Integration of 1 by cos square x into 4 plus tan x whole power 4 dx equal to. So 4 options are given. Okay. Now look at this problem. At the moment you can't identify function and derivative, correct? But what is derivative of tan x? Secant square x. Derivative of tan x is secant square x. You can see cos square. 1 by cos square x is secant square x. So this can be written as 1 by 4 plus tan x whole power 4 into 1 by cos square x is secant square x dx. Correct? Okay. Now you can see presence of function and derivative. So do it by method of substitution. Put t equal to 4 plus tan x, correct? Then dt by dx equal to secant square x. So that dt equal to secant square x dx. So this integral become 1 by t dt, correct? Secant square x dx become dt and 4 plus tan x is t. So 1 by t power 4. Correct, no? Okay. Now, what is integration of 1 by x power n minus 1 by n minus 1 into x power n minus 1? Use that formula. So 1 by t power 4. What is n equal to 4 here? So minus 1 by n minus 1. 4 minus 1 is 3. Correct? 3 into t power 3. Correct? T power 4 minus 1. 3 plus c. Okay? Which is equal to, now last step is substituting back t. Minus 1 by 3 into, but what is t equal to? 4 plus tan x. 4 plus tan x whole power 3 plus c. Correct? So which option? Minus 1 by 3, 4 plus tan x whole cube plus c. So first option. Next problem. Integration of sin 5x by cos 7x into cos 2x dx equal to. This is an NCERT problem. Now here you should do one trick. Right? You can write